We have used vectors as arrows and lists. Now let's understand the space they live in and three ideas that quietly underpin all of linear algebra: span, independence, and basis. They answer the question, what can these vectors actually reach? Take a single vector. Scale it up, scale it down, flip it, and it sweeps out an entire line through the origin. That line is its span, everything you can reach by scaling. Now take two vectors pointing different ways, combine them freely, and together they can reach every point in the plane. Their span is the whole two-dimensional space. But there is a catch. What if the second vector points along the same line as the first? Then it adds nothing new, you are still stuck on that one line. Vectors are linearly independent when each one points in a genuinely new direction. If one is just a combination of the others, it is redundant, dependent. This gives us the idea of a basis. A basis is a smallest set of independent vectors that spans the whole space. Just enough to reach everything with nothing wasted. In the flat plane, any two independent vectors form a basis. The familiar I hat and j hat are simply the most convenient choice. And the number of vectors in a basis is the dimension of the space. 2 for a plane, 3 for the space we live in. 768 for a word embedding. Dimension is simply how many independent directions the space has, how many numbers it takes to name a point. Why does machine learning care? Because real data often lives in a smaller space than it appears. 1,000 features might really vary along only a handful of independent directions. Finding that hidden low-dimensional basis is exactly what techniques like PCA do, compressing data by discovering the few directions that truly matter. So, vector spaces. The span is everything vectors can reach. Independence means each adds a new direction. A basis is the smallest spanning set, and its size is the dimension. And finding the true, small basis of your data is at the core of compression and understanding. Next, two functions ML cannot live without.